Imagine waking up tomorrow to find that the entire Antarctic ice sheet has instantly vanished. That missing ice would immediately release millions of cubic kilometers of fresh water into the oceans. Globally, sea levels would spike by roughly 60 meters in a single day. A spike of that magnitude would drown every major coastal city on Earth, erasing places like Miami, Tokyo, and New York from the map. This diagram compares the high solar reflectivity of white ice to a darker surface. Without that ice, the planet loses its albedo, its ability to reflect the sun's rays. Instead, the exposed dark bedrock and ocean absorb that energy, trapping massive additional heat. Physics dictates that an entire continent of ice cannot melt in 24 hours. This scenario is a terrifying fast-forward preview of the exact consequences we are currently locking in. The extreme volume of ice we imagined losing is already bleeding into the oceans right now. Recent satellite observations show that Earth has shed 28 trillion tons of ice since 1994. Global warming is accelerating this process through a complication called aerosol masking. Aerosols, tiny particles produced mainly from burning fossil fuels, actually have a cooling effect that hides the true scale of greenhouse gas warming. As global shipping regulations recently cut back on pollution, that aerosol shield began to thin. This ironically unmasked more as the underlying heat, driving temperatures up faster than previous models estimated. The apocalyptic overnight loss is a slow-motion, accelerating reality, driven by these complex variables. To understand the mechanisms of this ice loss, we have to look at West Antarctica, specifically the Thwaites Glacier. This cross-section shows the environment beneath a marine glacier. Deep seabed channels allow warm ocean currents to infiltrate and melt the ice shelf from underneath. That hidden flow eats away at the grounding line, where ice detaches from bedrock and floats, undercutting its stability. Atmospheric extremes and thinning ice are currently forcing this critical grounding line boundary further back inland. Look at this satellite view of the Petermann Glacier. The immense fractures and separating icebergs you see here provide evidence of structural destabilization and an ongoing grounding line retreat. Global coastlines face their greatest threat from the invisible structural collapse of marine ice sheets from the bottom up. This structural decay in West Antarctica is pushing the region toward a critical, irreversible tipping point. Floating ice shelves like Larsen C and George VI function as vital physical retainers, buttressing the millions of tons of interior land ice behind them. If these protective shelves collapse, models predict a massive cascade failure across the entire region. This simulation illustrates the aftermath. Without the buttressing effect of those shelves, trillions of tons of inland ice slide rapidly into the ocean. Crossing this tipping point triggers an unstoppable chain reaction, turning the slow-motion melt into the rapid sea level disaster described earlier. This photograph shows representatives of the Intergovernmental Panel on Climate Change. Their findings represent the international scientific consensus on our melting ice sheets. A major international effort known as ISMF6 recently generated new estimates of how melting ice will impact global sea levels by the end of the century. The projections show that melting ice sheets alone could add over 38 centimeters to global sea levels by 2100 under current emission levels. We will encounter severe milestones long before 2100. Researchers project we will reach peak glacier extinction between 2041 and 2055. During that ice, making the hypothetical 60-meter scenario an eventual reality. Can this trajectory be stopped or reversed? In targeted glacial engineering, massive subsea walls are built on the ocean floor to block warm currents from a glacier's grounding line. But models reveal a harsh reality. With only a 30% chance of success, barriers are overwhelmed as ocean temperatures rise. The only scientifically validated solution with a high probability of success is aggressive, immediate greenhouse gas emission reductions. The ice will not vanish in 24 hours, but our window to hit the brakes before the global map is permanently rewritten is closing fast.